it's Mrs. Trombley. It's time for lesson 5-2, perimeters and areas of similar figures. Last lesson we learned how to determine if figures were similar or not by figuring out if their side lengths were proportional. Now I'm basically going to give you two shapes that are similar, and we're going to use the fact that they're similar to help us find the ratio of perimeters and the ratio of areas. And remember, just a little refresher, perimeter is basically adding up all the side lengths. It's the distance around the object. And the area is what's inside. Area is so nice because it's inside that matters. Perimeter is so superficial. It's only the outside. So we'll start with that one and we'll end with the happy one. Okay, if two figures are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. The question I'm going to ask you today is I'm going to ask you to find the ratio of the perimeters in similar shapes. And all you need to understand is that the ratio of the perimeters is the same as the ratio of the corresponding sides. So for example, I have the perimeter of triangle ABC, meaning ABC right here, compared to the perimeter of triangle DEF. And I'm saying that side length AB, the ratio of side length AB over DE, is equal to BC compared to EF and AC compared to DF. And this is kind of what we just learned in the last section. All of those corresponding side lengths will simplify to the same thing. And I can kind of show you that here if I'm filling in the gaps here. So I have AB over DF. Here's AB, here's DF. Those corresponding ratios will be 2 to 4. Here's BC and EF. Those are 3 to 6. And AC and DF would be 4 to 8. So we know that these two shapes are similar because every single one of those ratios is equivalent to 1/2. They all simplify back down to 1/2. Or if you divided them, every single one, you would get 0.5, right? So I know that the ratio of the corresponding sides is 1 to 2. That means that the ratio of their perimeters is also 1 to 2. So the ratio of their perimeters is the same as the ratio of the corresponding sides. And what's kind of cool about that, if you look at this first triangle ABC, if you found the perimeter, 2 plus 3 is 5 plus 4 is 9. The perimeter of this second triangle would be 4 plus 6 is 10 plus 8 is 18. What's half of 18? 9. So the ratio of the perimeters for these two particular triangles is 1/2 because triangle, we'll call this triangle A and this triangle B, because triangle A is 1/2 of B. So that's how you can kind of use that. All right, let's take a look at what some of the examples are like, and then that can help all these words have more meaning to them. Okay, number 1, finding the ratio, find the ratio from A to B of the perimeters of the similar rectangles. So if I ask you to find a ratio of the perimeters, all you need to do is find the ratio of the corresponding side lengths, which would be 4 to 6 because I want to go from A to B, and simplify it. It's really that easy. 2/3 is the answer because the ratio of the perimeters is the same as the ratio of the corresponding sides. Hopefully so far so good. For number 2, I didn't give you a picture. Sometimes you will just have words, and I want you to be prepared for all situations. The height of figure A is 9 feet. The height of a similar figure B is 15 feet. What's the ratio of the perimeter of A to the perimeter of B? So I want A to B again. I'm going to set up a ratio here. It says the height of A is 9. The height of B is 15. So this shows me the height of A compared to the height of B, so I'm going from A to B. And when you simplify 9/15, because I always want these in simplest form, you get 3/5. That means that the ratio of the perimeter of A to B would be 3/5. I know, it seems like it's too easy. I'm not lying. This is it. All you need to do is simplify the ratio of the corresponding sides. Okay. Now this was a little bit more challenging, but it involves proportions, which you are awesome at, I must say. The ratio of the perimeters of two similar figures is 3 to 5. So right now I gave you the ratio of the perimeters. So this time I'm not asking you for it, it's given. If the perimeter of the smaller figure is 21, what is the perimeter of the larger figure? Okay, I'm hoping that you're seeing, we've talked about this quite a bit, that you are, right now, you're given 3 out of 4 pieces of information and a ratio. When that happens, It should be a blinking light that, ooh, I should set up a proportion for this. So I give you the ratio of the perimeters is 3 to 5. So I'm going to set that up in fraction form, because when we solve proportions, that's what it looks like. Then you are told that the perimeter of the smaller figure is 21, right? So when I have 3/5, if I know the smaller one is 21, I'm going to write the 21 across from the smaller number, across from the 3. And I'm trying to figure out the perimeter of the larger figure, so I'm going to plug P in for the denominator here. So basically I want to know 3/5 is equal to 21 over what? Because the ratio of the perimeters right here is equivalent to what I'm going to actually get on this side. So from here, I think we're home free. You know what to do with this, right? We're going to use cross products right here to set up a one-step. So 3 times P, I'll set it up over here, is 3P. And when you take 5 times 21, you get 105. Now all we need to do is get rid of the 3, so P can be by itself. And we're left with 105 divided by 3, which is 35. So the perimeter of the larger figure would be 35. If any of you said, well, I know that 3 times 7 is 21, and 5 times 7 is 35, then you could have answered it that way as well. The cross products property works every single time, not just when there are easy peasy numbers like this one. But I'm not opposed to you using other strategies as long as you show me what strategy you're using. Okay, so that's the perimeter. Perimeter, again, it's the same as the ratio of the corresponding sides. Turn your paper over. This one is similar to that. Haha, pun was intended. Was that punny? I thought it was very punny. Not really. Okay, anyway, I'll stop now. Area of similar figures. If two figures are similar, then the ratio of their areas is equal to the square of the ratio of their corresponding side lengths. So with area, you know how area is always units squared? This makes sense. All you have to do for area is you find the ratio of their corresponding side lengths and simplify it, but then you have to square it. And again, area is squared because you're counting, you're trying to figure out how many squares make up the inside. I said area was the nice one because it's on the inside that matters. So this is the same concept here that we did on the front, when you compare those side lengths and square it. So I can kind of give you a little example here. We'll fill in these blanks. Maybe you can do that on your own and press pause and come back. But for starters here, I have AB over DE. Well, first off, here's AB. AB is 5. And if you look at DE, DE is 10. So I'm going to write 5 over 10, and there's a squared up here. Then I want to fill in the blanks here with BC over EF. So BC is 10, EF is 20, and I'm going to fill in my squared. AC is not listed. So don't worry about that one for now. Let's just start with these two. We already know I used the same triangles from the front. This will prove enough of a point, so we're fine. Okay, if I simplify 5/10, that simplifies to 1/2. And if I simplify 10/20, that also simplifies to 1/2. If we square those, that means I'm taking the numerator and squaring it and the denominator and squaring it. So if I square 1, 1 times 1 is 1, and 2 squared, 2 times 2 is 2. Or sorry, it's 4. I don't know what's going on. It's the afternoon. I'm used to doing this in the morning. All right, so this is 1/4, right? Now, if you found the actual areas of these, this is a triangle, right? So actual area of a triangle, you're supposed to take base times height divided by 2. Or you may have seen it as 1/2 times base times height. Same thing, divided by 2 is the same as multiplying by 1/2. All right, so the base here would be 10. The height would be 5. 10 times 5 is 50, and 50 divided by 2 is 25. So the area of this shape would be 25. If I found the area of this other similar triangle, I would take the base times the height divided by 2. So 20 times 10 is 200. 200 divided by 2 is 100. Now, we said over here that the corresponding side squared is 1/4. What's 1/4 of 100? What's 100 divided by 4, or 100 times 1/4? it's 25. So the ratio of the areas of these similar shapes is 1/4 because the starting shape is 1/4 of the ending similar shape. So you can't just leave it as 1/2 because 25 is not half of 100. You have to square the ratios. Okay, let's try a couple of these. I think the examples always help everything make sense. I have find the ratio from A to B of the areas of the similar triangles. So what I want to know is, what is the ratio? That's kind of like what we were doing here. So all you have to do to find the ratio of the areas is match up the corresponding side lengths and set it up as a ratio. So 6 to 10, because I said A to B, and this is triangle A and that's triangle B. I'm going to say 6 over 10, and I'm supposed to take that, simplify it, and square it. So 6/10 simplifies to 3/5, and I need to square that in order to get the ratio of the areas. So 3 squared, that means 3 times 3. 5 squared means 5 times 5. So that would mean that the ratio of these areas is 9/25. So it's basically the same thing as perimeter, except at the end you have to square the result because area is square units. Okay, number 2, I take away the picture, and this time it's just words. The base of triangle P is 8 meters. The base of similar triangle Q is 7 meters. What is the ratio of the area of P to the area of Q? So I want to go from P to Q. I should have used DQ because it's ice cream season right now, isn't it? Anyway, so I want to go from P to Q, and we said that the base of P is 8 and the base of Q is 7. So right now I have the ratio of their corresponding sides. I'm supposed to simplify that and then square it. What's kind of nice is that there's not a number that goes into 8 and 7 other than 1. So this is all set. So once we square that, you end up getting 8 times 8 over 7 times 7, because squaring doesn't mean multiplying by 2, it means multiplying it by itself. So we end up with 64 over 49, and since I'm asking you for a ratio, we're done. Leave it just like that. I want it in the form of a ratio where I'm comparing 64 to 49. So that would be the ratio of the areas. All right, last one, and this is a similar application problem, kind of like number 3 on the front side. It says, you place a picture of a cute little Yorkie dog. Isn't that adorable? Yeah. You place a picture on a page of a photo album. The page and the picture are similar rectangles. So I'm sure you've seen a photo frame like this. This is just an album. There's 2 parts to this. A, I'd like to know how many times greater is the area of the page than the area of the picture. And letter B, I ask, the area of the picture is 45 square inches. What is the area of the page? So with this problem, you can kind of see how you can use the ratio of the areas to help you out. So letter A first says, how many times greater is the area of the page than that of the picture? Well, let's compare the 2. So here is, you're given the side length of the page and the side length of the picture. And I want to know how many times greater the area of the page is than the picture. So we're going to start with the page, so this is letter A, and compare that to the picture. Now all we need to do, because what this is basically asking you is, what is the area? What is the ratio of the areas? And we can do that. So we're going to take this. I want to simplify it first. So you end up having, you have 4/3. 2 goes into 8 4 times, 2 goes into 6 3 times. Now I'm going to square that because it's the ratio of the areas. And 4 squared, 4 times 4 is 16. And 3 squared, 3 times 3 is 9. So we'd have 16/9. That's A. This is how many times greater the area is of this page compared to that. And that's basically what we had done up here. I went from the 25 to the 100, and we said it was 1/4. The 16/9 is the same concept here. Okay, letter B. It says the area of the picture is 45 square inches. What is the area of the page? Okay, kind of tricky here. I know that the ratio of the areas is 16/9, and then you are given this 45, right? So I'm going to set this up as a proportion. I have 16/9, right? And notice this is the page, this is the picture, I tell you the area of the picture is 45 square inches. So where do I put the 45? The area of the picture, right? The smaller one's the picture. I'm going to put 45 across from that. And then up here we're trying to figure out this. I'll just use P again. Why not? And from here we can set up a nice little one-step equation. 9 times P is 9P. And when you take 45 and multiply it by 16, you get 720. Now, so I have 9P equals 720. I have to divide both sides by 9. And when you take 720 and you divide it by 9, you get 80. That means that it would be 80 inches square. That would be the area. I guess I should have used A instead of P, because now it seems like perimeter, but it's not. All right, so anywho, I'm hoping that you're seeing how these are related. Perimeter, just find the ratio of the corresponding sides. Area, find the ratio of the corresponding sides, and then simplify and square it. And you can always use proportions to help you figure out missing pieces when you're given 3 out of 4 of those pieces. See you later.